Hey folks, welcome back to another video. Today we're looking at question 895, maximum frequency stack. The way we'll be approaching this problem is by using two hash maps. One hash map will be used to map the number to the frequency itself, and the other map that we will be using is will be mapping the frequency to the numbers that actually have that frequency. So let's jump right in. First, let's initialize the things that we need. Let's have a hash map of integer, which is mapped to an integer as well, and let's call it f, a hash map that has an integer that maps to a stack. And the reason why we're using a stack is because even though we know the frequency at which the elements are coming in, we need to keep in mind this particular point. If there's a type of the frequency, we need to pop the most recent element that we saw. That's the reason why we have to use a stack. And in the end, we will have an integer that will keep a track of the max frequency that we've seen so far. Right. So within the public method itself, let's initialize all of that. So f would be equal to a new hash map. The same would go for the map itself. And the max frequency, let's just initialize that to 0 for now. Perfect. So let's look at the push method first. As soon as we get a particular element, which is x, we need to push that. But before we do anything, let's just get the frequency of the current element. So we would get frequency would be equal to f.get or default x or 0 plus 1. The next thing that we need to do is update the frequency itself. So let's say max would be equal to mat.max of the frequency that we're looking at right now, or the max previously, so that it's easily accessible. And you would also put that into the frequency map. So map.put x as x and frequency, and also we need to update this particular element in the map as well, that does the mapping in the other direction from frequency to the number of elements itself. So let's check if this element actually exists. So map, if it doesn't contain the key, the current frequency that we're looking at, we would just add that. So map.put, we would put frequency and then like a new stack. Right. And then once we make sure that the stack is available, we would just put that back in. So map.get frequency dot add x. Perfect. So all of this takes care of updating all of the variables that we have initialized right here, making sure there's a mapping between the element that's given to us, which is x, and the new frequency itself, either by updating it or by actually putting in a new element. The next thing you need to do is also update the map, which tracks frequency to the number of elements that correspond to that frequency, which we are doing right here. And the other thing that we need to do is update the max frequency if it does exceed what we have seen previously, which we're doing on line 20. Perfect. So let's do popping. So the thing that we need to do is int x would be equal to map.get frequency, max frequency dot pop. And the reason why we're doing this is because we want to get the most recent element that had the maximum frequency. Once we have that, in the end we would return x, but there are a couple of things that you need to do before that. The thing that you need to do is you need to update the map. So frequency, the map f dot so map.put x, and then you would decrease the frequency by 1, and so that's updating f, and you need to update map as well. Do we have to? Not really. Since we're popping it here, we don't really have to take care of the map. But if the max frequency stack is empty, you need to decrement the max frequency. So you would check if map dot get max dot size. If it is equal to 0, that means there are no elements that no element that remain that map back to the main frequency. So you would have to decrement the frequency itself by 1, and you would in the end return x. Perfect. So those are all the steps that you need to take in push and pop. Let's quickly compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Perfect. So let's quickly talk about the space and the time complexity. The time complexity of the of both of the methods is of 1. Since all of these operations that you're looking at are O of 1 operations, so it would be constant time for push and pop. The space complexity, however, since we are using additional data structures which are 2 hash maps, so the space complexity would be O of n. Perfect. So that's a solution. If you have any questions, please let me know in the comments below. And please don't forget to subscribe. I would really appreciate that. And if there are any other questions on LeetCode, if you would like me to solve, also let me know in the comments below. I'll see you all in the next video. Peace.